Hello friends, today I'm going to solve liquid problem number 519 Fibonacci number. So what's a Fibonacci number? Basically it's a sequence, and in that sequence a value at a given sequence is found by summing up the previous two values. So for example, in Fibonacci number it always starts with 0 and 1, and now to find the value at this particular sequence, next value, we are going to sum up these two values. So the value becomes equals to 1. Next we sum up these two values to find the next value, which is equals to 2, and so on. So basically we get 3, and then 2 plus 5 3 is 5, and then 5 plus 3 is equals to 8, and so on. So this is how we form our Fibonacci sequence. So basically the base case in this Fibonacci sequence is we should have the first two values to find the rest of the values, right? Because the value at a given point depends on the value at previous two indices, right? And for that we need to have the previous two indices. So this is about Fibonacci sequence. Now in this problem we have to find a Fibonacci value at a given index. So if we are given the index, this is index 0 1 2 3 4 5 6. Okay, so for index 6 we have to find the value at the Fibonacci sequence. So how do we find that? So basically index 6 would depend on the previous two values at previous two indices, right? So index 6, f at index 6 is equals to f at index 5 and f at index 4, right? And we know that f at index 5 is equals to f at index 4 plus f at index 3, and similarly f at index 4 is equals to f at index 3 plus f at index 2, and so on, right? So basically for 6 we need the value of 5 and 4, and for 5 we need the value of 4 and 3, and so on. So basically what are we gonna do here is it kind of tells us that we are going to do recursion over here, right? Since to find the value of 6 we first need the value of 5, but to find the value of 5 we first need value of 4 and 3, and for 4 we need 3 and 2, and so on. So basically we are going to perform recursion in this step. Okay, so if we are going to perform recursion, let's just write our code for recursion. So basically our base cases would be, if the value of n is equals to 0 we return 0, if the value of n equals to 1 we return 1. So if the value of n is less than equals to 1, we are just going to return the particular value, that is n. And now if the value is not less than equals to 1, then we are going to calculate for that given index, right? So in that case the value would be fib of n minus 1 plus fib at n minus 2, right? The previous two values. So these two values would form the Fibonacci at index n, right? And basically Fibonacci at n minus 1 we need to find it, so we are doing recursive call, and from that recursive call our Fibonacci sequence will be returned. Okay, so this will return our final result. Now let's try to run and see if this works or not. Alright, so all our test cases are being accepted. Now let's talk about time complexity and space complexity. So if you would look at this problem, we are calculating the Fibonacci for each of the values. Like, okay, let me just draw a tree so that it's easier for us to visualize the Fibonacci. So we want to find the Fibonacci at index n. So for that we need Fibonacci at index n minus 1 and Fibonacci at index n minus 2. Okay, now to find Fibonacci at index n minus 1, what do we need? We need Fibonacci at index n minus 2 and Fibonacci at index n minus 1 n minus 3, right? Previous two values. And similarly for n minus 2 we need Fibonacci at index n minus 3 and Fibonacci at index n minus 4. Okay, and so on. So that would be Fibonacci at index n minus 3 and f at index n minus 4. And here again we are going to find this value as well. So basically we are going to do it for all of these, right? We are going to perform the same thing for rest of these. So if you would look at this tree, what are we doing here? We are finding the value ones. Here we are going to find the value for two of these. Here there are four different Fibonacci's that we have to calculate. Here we have 1 2 3 4 5 6 7 8, right? 8. So if you would look at this trend, what's happening? It's going in 2 to the power n, right? 2 to the power n steps. So basically that's what our time complexity becomes in this case. So in this recursive problem, our time complexity is equals to 2 to the power of n, and space complexity is O of n, right? Because we are going to perform recursions, and while we are performing recursion, we are going to use stack. So basically our stack would be of size O of n. So this becomes our time complexity. So can we reduce our time complexity? Let's look at this graph over here. Now what we are doing here is we need to find the Fibonacci of n minus 2. So here we are doing that thing over here, right? And same thing is being repeated over here as well. So we are trying to find Fibonacci of n minus 2 at two different places. And also if you would look, we are trying to find Fibonacci of n minus 3 here, here, and again here. So we are repeating our task. So instead of repeating our task, what we can do is we can just store the value of Fibonacci at n minus 2 at a memory location, and then we can access the memory location once we are trying to again find this Fibonacci of n minus 2, and same we can do for n minus 3 and so on. So that would basically mean that we are performing dynamic programming. So in that case, our tree would become of time complexity, our time complexity would become O of n, and our space complexity would still remain the same. So we can actually use this scenario for solving this problem. So for that, let us just define a global variable dp equals to, well, this is not what we should do, but let us just define it, equals to our array. And now here our array would first have 0 and 1 values, right? So these are the first two values, and in this case so if we already have dp at index, and we are just going to return, okay, let me just make it small, return dp of index n, else we are going to calculate the Fibonacci at that index, at those given indices, right? So so for that we are going to do dp of n equals fib of this. So we calculate our Fibonacci for n, and we store that value in our dp because we might want to retrieve it later on, right? So in this case our time complexity becomes O of n. Let's try to run and check if this solution works. All right, so this solution is working well as well. And now this is O of n time complexity and O of n space complexity. Can we solve it in much better space complexity? Like, can we reduce the space complexity? Well, talking about time complexity, we cannot reduce the time complexity because to find n, we will have to start from the first to find the value at this given index, right? So basically one iteration is required. So O of n time complexity is what we will be requiring. But can we solve it in constant space complexity? Well, yes, of course. So if you would look at this sequence, the value at this particular index depends on these two values, right? So we only need the previous two values to find the value at this index. And what about this? We only need the previous two value, which is 3 and 5, to find the value at this index. So basically we can reduce our space complexity here. So what are we going to do is we are just going to perform iterative approach over here. So we are going to store the first two values at our constant variable, so that would be a equals to 0 and b equals 1. And now for let I equals we're starting from index 2, right, and I is less than n I plus plus. So what we do is we keep on, we have the first two values, right, index 0 and index 1. Now we need to find the value at index 2. Okay, index 2, so that's why we are starting from index 2 until I equals less than equals to n. Okay, so we need the value at index n. So now at index at this index, what are we going to do is we calculate the value at index 2, which depends on the previous two values, which is a and b, and now we update our value of a and b. So we found our value at this index, which is 1, and now we are going to update the value because we want to find this. So now our a is equals to value at this index, b is equals to value at this index. So a becomes equals to b and b becomes equals to c. Okay, and so on, and finally our answer would be at c. Okay, so now let's try to run our code and check if this works well. Okay, so we got an error. All right, so we can basically return the value b because b is assigned to c. I mean c is assigned to b, and here c is a local variable, so I cannot access c over here. But since the value of c is assigned to b, we can return b. So let's run this again. Awesome. So in this case, we are able to solve it in constant space complexity and of n time complexity. So yeah, I hope you liked my solution. Let me know in the comments down below, and thank you so much for watching till the end. Please like and subscribe.